No, yeah, that's why we're here. Okay, so I'm going to just move this around as needed. So this is sheet 1. This is sheet 1, the big version.
Gotcha.
And then this is
the electronic
the
version.
electronic version. So go ahead and read what you got going on here.
And I can write on everything.
You can write on anything and everything. Please do anything that you want to write on. Remember to talk out loud as you're working and to think about the problem, basically, both in writing and while you're working.
Gotcha. Okay, I'm gonna like pull this over here then. In the sketch, we'll see a triangle with its 3 interior angles colored in. Change it by dragging a vertex. I would like you to tell me what you noticed about the angles. Okay. So when I move this angle further up here, the green one gets bigger or more obtuse, and the blue one gets more narrow, more acute. And if I move it over here, at this point, the pink and the blue are pretty much equal, so it's like an isosceles triangle now, because the green one's a bit bigger than the other two. And then if I put it back, like maybe right about here, it's not perfect, but now they're all equal.
Cool. Maybe try this slide me tool. See what happens.
Whoa!
I know, pretty cool, right?
That's crazy. So this is like the exterior angles. Not the exterior angles, but like the angles that are outside the triangle.
So the angles outside the triangle would be called exterior angles. We are working with interior angles. They're just moving the interior angles, so they're keeping them as interior angles. They're just moving them. So you might be able to see a relationship.
Gotcha. So like here, I guess here's where you can tell that they're all equal. Because it's like
why?
a straight line across 180 degrees. They all match up to each other. Boop.
You want to change the triangle around a little bit more and see if that still is the case?
Sure, I'll make it like super all over the place. Yeah, so it's not. Okay. So now obviously all the angles are like, they're different sizes, but whenever you move them, they still line up. Well, I guess that's because all the angles in the triangle have to add to 180. So that actually makes a lot of sense. That makes too much sense. So
Awesome. Do you have anything you want to write down about the triangle before we go explore the next shape?
I feel like this just really emphasizes that all the angles add up to 180 degrees.
Okay. Why?
So,
Why does that emphasize that?
Because no matter how I slide this thing around, whenever the angles always meet up, they always, right here, they don't form a straight line, but like they like come across. Do you know what I'm saying? Like there's all the angles together results in that straight line, which is 180 degrees.
Okay. Cool.
So like not the best way I could have worded it, but like I think it makes sense. Okay, so all angles add to 180 degrees. And then I guess I could just write that well, actually no. I guess that's just pretty much the gist, because no matter how I move the triangle, like it's gonna be the same. Like I could put it like over here and it would still do that. Okay, so do I click this button now, or what's the next step?
Nope, next step is to explore the interior angles of a quadrilateral. So now we're going to look at what happens with these interior angles of a quadrilateral.
Gotcha. Okay.
You understand what the problem's asking you to do?
Tell me what you notice about the angles. Yep. So, same type gist. That one, oh, it has a circle around it. Oh, I was like, why is it switching back? And then I realized it's because I was dragging it to the reset button. Now it looks like a kite. Whoa. That just did some crazy things.
Okay, talk to me about what you noticed.
Okay, well, as soon as I did this, and then it brought me here, you know, it shows that, I just whistled, that the quadrilateral was divided into two triangles.
Okay. Is that going to happen for all quadrilaterals?
I would think yes, because I can move it here or here or here, and it's still two triangles that it's divided into.
Interesting. So what does that tell us about the interior angles?
That they add to 360. Wait, 180 plus 180 is 360, right? I'm not like tripping. Okay.
No, you're not tripping.
So, because all the angles in this triangle, they're gonna add to 180, just like in every triangle. And then same with this one, so it's just interior angles add to 360, no matter which way you flip it. This is really fun to do.
Don't worry, you have lots more to explore. So, have you tried all the different types of quadrilaterals? Are we sure it's the same? What happens if you if you make a concave quadrilateral, so you make it like this?
Oh yeah, I think I did that some, like this.
Yeah, you did have one like that, yeah.
Like here?
Yep.
Still triangles.
Still triangles, okay.
Triangle.
Cool.
Wait, this one looks weird.
That one maybe you made a big turn. Oh, there it goes. I don't know what you did there.
I don't know what I did here either. That's a funky looking thing.
Is that because this is a vertex? What is that?
Yeah, oh, I see what it did. Okay, so it like filled in this space.
Got it.
Here. Yeah, because that is a vertex. Gotcha. Okay. Should we slide on? Or?
Yeah, you want to make a note of what you noticed?
Sure. In every quadrant, it's fine. Lateral. There are two triangles which total the interior angles to 360 degrees.
Cool. Moving on. Go check out the pentagon.
Fine. Alright. I'm gonna go ahead and slide this thing. There's 3 triangles now. So basically, I think what you're trying to teach me is that everything is made of triangles.
Oh. Yes. Polygons. Have lots of triangles.
That's new.
Yeah. That's called a crossed polygon. By some definitions, it's not a polygon. By others, it is.
What do you define it as?
A crossed polygon.
Do you find it as... Does that mean you believe it is a polygon?
I believe in some classifications it's useful to have it as a polygon, and in others it's not.
Such a Margaret answer to give. Here we go. 3 triangles. Once again. Oh, this is like the whole circle thing. Because it's like, you know what I'm talking about? Like,
I don't know.
alright, because you see we got circles here.
Uh-huh.
That's obviously, you know, the 360 degrees, the circle. But then, does this go back to like unit circle and like moving
All the way around.
all the way around? Because you go from like triangle 180 to quadrilateral 360 to moving back around to, what is it, 270?
Well, that's under 360, yeah.
Oh, yeah.
What would happen if it's...
Or,
Is that how many we have here? 270?
no, I'm trying to, what's 360 plus 180?
Remember, you can write it down if you want.
My ability to do math in my head is not too keen, especially since I just, for some reason, was doing subtraction, but it's fine. 540. Oh, that makes such sense because, like, there's a kick called a 540, which is where you spin 3 times.
Interesting. Yeah, that would make sense.
Okay, so then would all the angles in a pentagon equal 540 degrees?
Do you think?
I think that 3 triangles is 540 degrees, and there's 3 triangles in a pentagon.
Do you think it'll make 3 triangles every time?
Aside from that weird crossed polygon thing I did, yes.
Why?
Because, like, why is it every time, or why does it equal what it equals?
Why does it make 3 triangles?
Because there's 5 angles. And you can draw points from each of the angles to make 3 triangles.
Interesting. Okay, cool. Let me see if I need to... All right. You ready to go explore the next one?
Yes.
Do you want to write down anything?
All pentagons excluding the crossed ones or I should say, well, what would it be? Like all pentagons add up to 540 degrees? Because that's not exactly what I'm saying.
Right.
Like all the angles in a pentagon.
Okay. Interior angles, maybe?
Yeah. All interior angles in pentagons. There we go.
Cool.
Add up to 540 degrees. There we go.
Cool.
Cool.
All right. Check out the hexagon. Do you have any predictions?
going to take a wild guess and say that this goes up to 720.
Where's your guess coming from?
That I know that there's going to be another triangle.
Oh.
And also because the one kick up from a 540 is a 720.
There you go.
Wow, I was exactly correct.
Yay!
Can I just go ahead and write something for this?
Yeah.
Okay. So, all the interior angles in a hexagon add to 720 degrees, aka there's 4 triangles.
Cool. All right, you want to go check out the heptagon?
Wow.
What do you predict is going to happen?
I predict there's going to be 5 triangles. And I don't know the kick above 720, so I'm like not able to do that math in my head. Oh, it's called a heptagon when it has 7?
Mm-hmm.
You would think that they'd pick a name that's like far off from hexagon.
You might think. But in every language, 6 and 7 are very similar numbers.
Oh, that's true. I don't know why. Yeah, but you know. Okay. So, no surprise. There's 5 triangles. We're gonna quickly discover what 720 plus 180 is. $900. I did know that. There is a kit called a 900.
Wow. That sounds like it would make me dizzy.
Yeah. I don't know anyone who can do it.
And how many triangles are there?
5.
Do you want to write that down?
Yeah. So, in every hexagon, or heptagon, see what I mean? See the brain cells? In every heptagon, there are 5 triangles, which is actually really cool because there's just always triangles.
What do you think is going to happen in the octagon?
I'm going to take a wild guess and say that there's going to be 6 triangles, but I could be totally wrong. So.
You want to go confirm?
Yeah. All right, let's move. Here we go. Oh, I'm going to make it look weird first.
Okay.
I'm going to play with it. There. I think I made it look too weird. Wow.
Filled in some
Let's
triangles.
do that. Okay. There we go. 6 triangles.
So your prediction was right.
I must say that is the case.
So what do you think the number or the degrees of the interior, some of the interior angles is?
Okay, I should be able to do this in my head. This is like a solid number. So it's like 1,020, right? Or no, because we're not adding 20s. We're adding 180, so that makes no sense. Would be 1,080.
Uh-huh.
That was the ADHD coming out.
That's okay.
So 1,080 degrees. 6 triangles or 6 half turns. Should I write that?
Sure.
6 half turns. One, 2, 3, 4, 5.
I think this one was... One of them was extra. You can count these 1, 2, 3, 4, 5, 6. Right?
Yeah, that would make sense.
I'm seeing 7. 7 of the line. Oh, is that a line down there? We need to make it smaller. 7.
I think we discovered something new in math.
What did we discover?
That there's 7 whenever it's indented.
Yeah, the math word for it is concave. Yeah.
Concave. So should I write that?
Yeah.
When
Is that true? Up here too?
an octagon,
You made a funky, you made a crossed one.
yeah, is concaved, there's 7 triangles, which is pretty wild. It goes against the wall.
Whereas a concave heptagon seems to work. Just
Must be an octagon thing.
That doesn't make sense to me. I'm supposed to be looking at your thinking, not my thinking.
It's okay.
Just curious. Okay. Can you make any predictions about nonagons? Because we don't have one. We're at the end of our playtime.
I would predict that a nonagon has 7 triangles
Okay, why?
because each time that we've added an angle to our polygons, there has been a new triangle also added.
Okay, what about a 20agon?
18.
How'd you get that?
It's just subtracted 2.
Why'd you do that?
With every one, like an octagon has 6 triangles, a heptagon has 5. So it's just the number of angles minus 2 equals the number of triangles.
Cool. So what would you say about an n-gon?
How many angles is that?
N,
What?
it's unknown. A variable number of angles.
I would say that it's whatever you want it to be.
Oh, really? What about a 100gon?
Would that be 98 triangles?
Why do you think so?
Just subtract 2.
Okay. What about a 1,000,000gon? Oh, well, that's hard math.
9, something, and something, and 8.
Okay. What about an n-gon?
That's still that unknown variable one.
Uh-huh.
To be n number of triangles.
Oh, so now it's n number of triangles. So in the 20gon, it was 20 number of triangles.
What?
If an n-gon has n sides, how many triangles does it have?
N minus 2.
Oh. What's the sum of its interior angles? We can go back. What's the sum of the interior angles of a 20gon?